In our books, chapter 41, they said that there's 3 ways to make a list. Okay, there's more, but these are 3. The only one we're concerned with is right here, because we're not going to learn about linked list or vectors. You may remember from before, it's okay to put your interface on the left and declare your object like that, but you have to construct from an implemented class. You can't put an interface or an abstract class over here on the right to construct from. So there is an ArrayList class. Yesterday we actually looked up the source code of list. We could look up the source code of ArrayList if we wanted to, but it wouldn't really serve a purpose for right now. Okay, but like we saw in our book right there, okay, so here's the syntax. Like I'll say list1 is a new. Now again, what I can't do is I can't do this. I can't say new list. Okay, that's abstract. It's an interface. But what I can say is that it's a new array list. And like we learned previously in our interface study, it would be perfectly okay to put the implementing class on the left also. And so you will see both of these things as we start looking at Java code. The College Board will use both. Okay, we'll use both. Textbooks will, whatnot. So, and it really doesn't matter much because all of the methods are in the interface. So we don't ever have to worry about like a downcast to reach a method that's in ArrayList but is not in list or something. And we don't really have to worry about any polymorphism type stuff because all of the implementation is happening in ArrayList anyway. Remember, the interface list just declares the methods. It doesn't actually like say what to do. So it's not like we have to worry about an override trick or anything. So the difference between these 2 lines of code is pretty minimal. I mean, technically, the first line of code would allow me to switch my object later to a linked list or a vector. We're never going to do that in our class. So you guys go on in your study of comp sci, maybe you will, but not us, okay? Now, a list can hold any type of object. And literally, we mean any, okay? Remember the super cosmic class object? You can put anything in here. So you could take that list, like list1, and you could add to it, say, like a string. Okay, that would be perfectly okay. You could also add to that list like a Boolean. So I could say false. And I could add to it, a double. And I could do any of these things to that other list too, list 2. So if I wanted to go to list 2 and add an integer, I could. And I could add a char if I wanted. So like all of these things could be added into my list. But you'll notice I get this kind of weird, I don't know if we've ever had a compiler warning before. So this isn't a compile error. It's not quite as bad as that. And it actually let me compile, but it gave me a warning. I could still go ahead and run this program, but they're kind of warning me like, oh, be careful. All right. And I'm going to show you guys in a couple minutes, we'll get rid of that compiler warning. I'll show you how, and I'll talk a little bit more about why we're getting it in just a second. Now, there's some weird things about being able to put anything into a list, okay? Anything can go into the list, but when it comes out of the list, it comes out of the list as an object. Now, what that means is it's going to behave a little bit strangely sometimes. Okay, so for example, like if I say out.println and I take list1 and I get item 2, now that should be the 9.4, okay, because that was added last. and I add to that list 2, and I'll get the 0 item, and my thinking is that should be the 3. Oh, whoa, what is this? Bad operand type for binary operator. Okay, oh, so I must have done something wrong, right? Okay. What if I had just added 3 to that 9.4? Binary operator. Okay, again, so what's going on here is when that thing comes out of the list, I know it's 9.4, but the compiler strictly sees it as an object. Now, if I downcasted that object to a double, then it would let me add. Okay, so you can put anything into a list, but when it comes out of the list, it comes out as an object. So you have to actually cast it to what you want it to be. So same type of thing. Like imagine I took that first one in there. If I said out.println and I said give me list1 0. So list1.get0. Now I know that's a string. Well, what if I wanted to take a substring of that string with characters 0 and 2 only? Like, I should be able to do that. As long as this is a string, I should be able to do this. But it tells me it can't find substring. Now, the reason it can't find it is normally the string over here would point the compiler to the string class to find the substring method. But this highlighted thing here in yellow is not pointing to the string class. It's pointing to the object class. Now, if you point to the object class, you can only find object methods like toString and hash code and all that other stuff. There is no substring in the object class. What I would have to do is I would have to downcast to a string. Even that's not good enough because we've seen this before, that period, the access point, has higher precedence than my downcast. This is one of those things where I have to put in like an extra set of parentheses around it, and now it would finally let me. Now it would be like, oh, okay, it really is a string. Go ahead and take a substring of it. The compiler warning is telling me like, hey, you better be careful. If you start downcasting to things that don't really happen correctly, you're going to get some errors. Like, oops, I didn't want to do that. What if I had downcast to a string, but I had really pulled a double out of the list? Or what if I had downcast to a double, but I had really pulled like a string out of the list or something? So that's where the warning kind of comes in. All right, here's the good news. Okay, 10 years ago, kids taking the AP test had to worry about stuff like this, and they had to write code like this, and they had to downcast all the time with those parentheses. Okay, with Java 5.0 and auto unboxing, they've kind of gone away from that. And so many years ago, I don't know, like 7 or 8 years ago, the College Board decided that they would only give array lists that are what we call typed. Okay, and what I mean by that is they say up front what can go into the list, and therefore only one thing can come out of the list. Now, back to that quick reference really quickly. So, oops, it's over here. Okay, that's why we see this mysterious letter E here inside of a less than greater than. We've never seen that before. And you might notice how these return types are listed as E. That's kind of odd. Now, yesterday in our textbook, those return types were listed as object, which is technically correct. The return type of those methods is object. And that's why I was getting these weird things in BlueJ. When I was using the get method, I was getting back literally an object, not a string, not a double. I was getting back an object, and I had to cast it to what I wanted. Okay, but if you look at the quick reference that the College Board provides, by putting that E there, they're promising you that any array list that you see will be typed to a certain type of object. And then that type of object will be promised to be returned by the get method, the set method, and the remove method. Okay? Now, let's see how we do that. How do we make this promise? Okay, the way we make this promise is just like what we see right here. Less than, greater than, and in the middle, we write the type of object that we're promising. Okay? So I'm gonna comment this out for a second. And when I do comment this out, it will get rid of that compiler warning in all future compilings. We shouldn't see that warning again now. And the next list that I make, right after the T, I'm going to put a less than, and I'm going to write the word string greater than, and let's go ahead, I'll call this one list 3, just picking up where we left off. And this is going to be a new array list. And again, on this side, I'm also going to write string, less than, string, greater than. Still have to put my parentheses there. Now, I know this is some really strange looking syntax, and sometimes kids have a hard time remembering it. But remember, like I said, we're at the end of our syntax part of the class. So the good news is you shouldn't be having to memorize many more things in here. Okay, but that is a weird one. But what we just did, basically, is we made a promise. List 3 can only hold string objects. Now, you might think to yourself, like, why would you want to do that? Like, why would you want to restrict the capability of an array list, right? Well, the good news is everything that comes out of this list is automatically cast to string. So you will not have to do any downcasting at all, okay? It will just automatically be a string when it comes out. Okay, so if I take list 3, I should be able to add any string that I want. If I want to add a cat string, I can. Okay, if I want to add a dog string, no problem. All right, but if I said list3.add and I put 42 in there, that should be a problem. Okay, because I made a promise. Oh, and now I made a promise to not put any integers into my array list. And when I make that promise, I got to hold that promise. Okay? So I can only put strings into now. And now notice for the first time I'm compiling and I'm not getting a warning anymore. No more warning. Okay? Because I don't have this mixed data type thing going on anymore. So the compiler didn't feel the need to warn me any longer. Okay, so if we're doing this right, we shouldn't see that weird warning message. All right, so let's just, we can try out some of the things, that we did yesterday. So like right now, if I took list 3 and I added, and this time I'm going to say index 0, and I'm going to say bird. Think to yourself, like, can you predict what this list currently looks like? Okay, well, it's actually really easy to find out what this list looks like. The authors of the ArrayList class built a very nice toString method. Now, this doesn't happen with arrays, right? What happens if you print an array or a matrix? You get some weird memory address, right? But the authors of the ArrayList class said, you know what? Let's go ahead and make a nice toString. And now, when I print it, I should get a nice representation of the current state of this list. All right, and there it is, bird, cat, and dog. And notice that bird is at the front, and cat and dog both shifted over one to the right. Okay? The reason dog's at the end of the list is when we added dog, cat was already at index 0, dog jumped to the end. That's the default add method. And then when I said, no, I want to put bird at 0, it got to go to the front of the list. Okay? If I did another add method here, if I said list3.add, and I said go to index 1 this time, and let's put an elephant. Okay? So what should happen is that elephant should take over index 1 from cat, right? But we don't lose the cat string. We should see everything shift over to the right. Bird would stay in the front, elephant would go to the index 1, cat and dog should shift to the right. Okay, you could print it if you wanted to verify it. All right, let's try like the set method. So if I say list3.set, and I'll go to index 0, and I'll put a hippo there. Okay, now I should lose bird from this list, right? So the current state of this list should now have hippo in place of bird. Remember, the add method always makes the list get bigger. The set method, it keeps the same size. Now, one thing about this is that method returns something. If I write the method like I have it right now, the return of that method is lost forever. So in other words, the bird string is now gone forever, and like we couldn't get it back. If I wanted to preserve that string, I could. Since the set method has a return, I could say string, maybe like word1 equals, and then I would have that string saved now. So later in my program, if I said, okay, let's go ahead and print word1, it should call up that word bird that we saw. Okay, so let's see if this is all working in sync here. Okay, so yeah, it looks like the state of our list was correct with what we predicted. Hippo took over bird, and then bird got returned later when I said print word1. Now, notice that, the program was fine with me not putting that there. Like, you don't have to save that return, but you could. Kind of like up here, like, remember technically that add method returns a Boolean. So, I mean, I could have done that. I could have said like Boolean b equals, and it would just been initialized to true. I just didn't really feel the need to, since I knew it was going to be true anyway. I just kind of left it alone. All right, so going back to that quick reference, you need the add method. You need the add method that specifies the index. You need to know the set method. Okay. You also need to know the get method and the remove method. Okay, so get and remove and size. All right, so let's just take a quick look at all three of those. So the size method, remember, returns the size of the list as an integer, and this has replaced length. So you're never going to write .length when you're working with an array list. On our first quiz, somebody will write .length, right? And I told you what was going to happen to their paper, didn't I? Did I tell you guys? No, I'm going to put it in my incinerator at home. And no, okay, all right. I won't really do that. Okay, but this should print 4, right? Our current list has 4 items in it. We can check that out in a minute. All right, and then also you have a get method. Now, remember earlier when I tried to get from the list, it wasn't letting me treat that as a string. Now it will. So if I say like string word2 equals, and I say list3.get 1, I don't need to downcast this anymore. Okay? There's no downcast required here. All right, it's automatically coming out of the list as a string, but only because I gave my list a type. Only because of that. And so if I wanted to, I could actually say like out.println, I could take, say, hippo, so list3.get 0, and I could substring it to 0, 3. Like this would be perfectly okay because whatever I get from that list automatically becomes a string. I can now apply a string method to it. In other words, when the compiler does this and it sees my highlighted code, it sees that it's a string and it points to the string class to find the substring method and its implementation. Okay? So it doesn't get confused now. It doesn't point to the object class and get lost. It actually points to the string class and finds that method. So again, no downcast needed. Up here, I had to do that real crazy downcast with all those parentheses. And kids used to have to do that. Just like 7, 8 years ago, they had to write code like that. I'll show you an old AP question that where we can see this happening. Now we don't have to worry about it. Okay? All right, so anyway, that's the get method. What was the other one we were missing? Let's see. Oh, the remove method. Okay. Now, the remove method also has a return. So in this setting, I would return a string. If I didn't save it, it would just be lost. But if I wanted to save it, I could. I could say like list3.remove2. And now it should be fine. Okay. If I print that, I should get cat. Okay, because that's in word 2. Oops. So index 2 was cat, so I think this would print cat. If we printed the list out again, we would see a 3-item list. Okay, so remember this is what the list looked like the last time we saw it. And if we took it now and we had removed cat, not only would cat be gone, but dog should be shifted over 1 to the left to take its place. So let's just kind of make sure this is working like we predict here. So yeah, we got the 4 from the size method. We got hip from the substring of hippo. Cat was the removed word. And now, just like we said, when cat got taken out, dog slid over and took its place. If we did the size of this list again, it would now be 3. So remember, with arrays, we couldn't do anything like this with arrays. Once you make an array, it's stuck at that size, okay, that length, unless you actually create a brand new one. But with an array list, we can add to it, we can remove from it, we can set, okay, we can do all of these things, all right? And so that makes it very useful to us. Now, it only works with objects. Okay, now just a couple things before I move on to something a little different. One thing is, if I came back up here and I put the word array here, nothing would change. Everything would still function, okay? So like I was saying, you know, whether you declare it on the left as an array or as an array list won't really have much impact on our class. Maybe with a parameter setting, I'll show you guys maybe something in the future we have to watch out for, but for the most part, really won't matter to us. I didn't do anything here that went out of bounds, but I easily could have, okay? If I had said, get me item 5 instead of 1, it runs fine at compile time. It's like, oh, okay, cool, he wants to get item 5, but when I go to run it, it's going to crash, okay? And I get my out of bounds exception, right? Right there, just like we talked about on the worksheet yesterday. So if I tried to get something, if I tried to remove something that wasn't there, it's going to let me compile, right? So often, once we get that compile, we think, oh, we got it. But once I run this, again, I'm going to go out of bounds. So out of bounds exception, okay? So just because it's compiling, you still have to watch out for those compile errors. All right, now, real quickly, why do we need wrapper classes? Well, here's why. If you tried to make an array list of ints, okay? So I make an array list. Let's see, I think we're up to list 4. All right, this is going to give me a compile error. You cannot make a list out of primitives. That whole type E thing that we saw on the quick reference, only can refer to objects. You can only type from object down. Like, it's kind of like you're specifying the level of downcast. And so there is no, you don't downcast to a primitive. That's called typecasting. That's a little different. So what I have to do, and it's not a big deal, if I want to make an array list of integers, I can. I simply have to use the wrapper class integer that we learned about 2 days ago. So that was really the whole reason I taught you guys about wrapper classes, is just for that right there. Once we put the word integer there, with all of that auto boxing and unboxing that we saw now, we don't really have to do anything else. Like, nothing weird's going to happen. You can put numbers in there, you can add them, multiply them, subtract them, whatever. You can do anything you want with them. Anything you can do with a primitive int, you can do with these. And you could even do other things with these integers. Like, you could do all those new methods we learned about, like 2 binary string and 2 hex string and all that if you wanted. Okay? Same exact thing for a double. So, like, let's say I wanted to make a double. Okay? If I put the word double here and I use lowercase d for double, and I make this list 5, and I could leave it as an array list or a list, it really doesn't matter. If I put a primitive double there, automatic compile error. So what's the only thing I need to change? It's this easy. I'll just change the first letter to an uppercase, and now it's a wrapper class double, which is its own class object, and I'm fine. And once I've done this, again, I can put doubles into this list. They'll come out as doubles. With auto boxing, auto unboxing, I don't have to do anything strange. It's going to be fine. I can do all kinds of math with them and whatever I want. Okay, and there shouldn't be anything weird happening. All right, that's pretty much it. That's the basics. This is our new syntax. And like I said, I know it's a little weird, but the good news is it's pretty much it. We're pretty much done learning new syntax now for the year. And these are the only methods you're required to know from ArrayList. Okay, that's it. You don't need to know all the others. And every ArrayList you see on your AP test or any of my quizzes or tests is guaranteed to be a typed ArrayList. So we won't see anything that just without that bracket E in there.